Great. All right, cool. So I guess like while we have this like extra time, the food is probably going to come around like 7:30 ish. So like just be prepared for that. While we have this like time while we're waiting for people to sort of trickle in, there are two big things. One is just like general announcements. The sprint tournament is next week on Tuesday, so submissions will close on Monday night. And other main announcement is that basically, if you're not in the Discord, please join the Discord because that's where we announce a lot of things, like what bug changes we have. You also like get to see on the Discord when people are having issues, so that you know that like you can like sort of help them or they can help you, and maybe it's like a shared problem that you guys have. So generally it's a like nice community and like they help like us improve and they help like each other code. The other part of today is that like we want to actually have we actually want you guys to like choose a language. I know that some people code in Python, some people code in JavaScript. Maybe like a majority of the people watching these lectures are coding in Java. So in any of these cases, I think Nate is about to make a channel for everyone on the Discord for people to vote on their favorite language. And so once we decide on that, we'll basically just continue coding example funcs player in that language for the rest of this lecture series. Oh, and also, I guess while we're waiting, let's open up like this to like general questions, issues, concerns, also to the Twitch chat.
The channel to vote in is called Lang-poll
Yeah,
on Discord.
Lang dash poll. Yeah. Are there any questions in Twitch?
Let's see. No.
Okay. Are people viewing?
Yes.
Oh, oh, 16 people.
Yes. 16 people on Twitch.
Yeah.
Should we? I guess I should announce that the lecture is starting.
Oh, yes. Oh, I announced in Discord.
Oh, okay, great.
Yeah. Does anybody want to just like shout questions or complaints at us while we're up here? Like suggestions for the viewer, the API, anything? Everyone's having a good time? Great. Yes.
So I'm having a lot of weird issues.
Uh-huh.
The latest one is that I switched to JavaScript from Python
Uh-huh.
because the Python gave me some issues. But my JavaScript file also started giving some weird issues, and then I moved the example JavaScript file into like just a different folder in the same directory,
Uh-huh.
and it gave a similar error. Like it gave the not solve error, I think.
Oh, is this like trying to import a file from another file?
Yeah, I think it's trying to do that.
Okay. I think once Guru comes, he can answer that a little bit more definitely. I've definitely had success like importing with if like the file is in the same folder as the bot itself, and then you just like import it into the bot.
Well, I haven't tried importing any of the part myself, but maybe the example is importing.
Oh, is this the example funcs player?
Yeah,
Hmm.
like that is.
Oh, okay. Well,
But it works in the example folder, not just not like in another folder that's in the same directory.
that's really spooky. And yeah, have you gotten like any other code to work?
Yeah, but a bit on and off. So sometimes it works without really any changes.
Yeah. So I think if you could wait till after lecture, I think Gru could probably talk to you a little bit more about the issues you're having. But definitely, like there are some times when like the compiler will compile wrong, or I think like half of the time I just get like blue compile error and then I just run it again and it works fine.
Yeah.
And sometimes it just stops. Hopefully, like the newer releases have fixed that. And I think just recently we had a fix to make Node 11 use, or like fewer bugs in Node 11.
Oh yeah, yeah. There was this weird thing with Python in Node 11 where like it would just totally bug out, but now that should work.
Great.
I And then we also fixed a bug with the term queue, which a lot of people had issues with. Like it used to be that, so again, it's supposed to be the like red, blue, and like actions, robots that are created in a turn get to move in that round. That was a little buggy, but we fixed that. We also fixed.
Do you want to stand over here so that Twitch can definitely hear you?
Yeah. We also fixed some bugs in like the give method, and so there was a bug in the Python starter package there, and then there was also a bug in the actual engine where you could only give to like positive DX or 0DX. So those should be fixed. Yeah.
Okay, great. So for everyone just coming in, we're currently trying to decide what language everybody likes the most. If you are,
No, not that.
huh?
That's definitely not what we're deciding. We're trying to decide which language we should demo for lecture
Oh,
today.
yes.
Unrelated to which one you like the most. Which one would be most useful for us to use in our examples?
Yes.
Yes.
So if you guys aren't currently in the Discord, please join the Discord. And there is a new channel called Lang Poll, LANG-POLL. And you can just vote on what language you would like to see example funcs player being written in. Great.
Oh man, JavaScript is catching up.
Oh, really?
5 to 6.
Oh, actually?
JavaScript, Python. Yeah.
Oh, okay, great. Because I like both of them. But,
Meanwhile, some people still think you vote by commenting in the channel.
oh, okay, yes. Please react. Oh, okay. Yeah, after we take this poll, you can definitely make this channel into a meme channel. Just like, for like 5 more minutes. Please hold on.
Oh, JavaScript is pulled ahead.
Oh my god,
Whoa,
what a life.
what an exciting. All right. In 1 minute, the poll is closing.
Okay, in 1 minute, 7:10 p.m. EST, please vote for what language you would like to see example funcs player being written in. If you go to the Discord, there is a new channel called Lang Poll. And, okay, yes, now we're, okay, well, JavaScript, someone's being very indecisive about whether or not they like JavaScript. It should be under questions over here, and it looks like everyone should have access to it. Yes. Oh,
All right. It's the very top message is the poll.
mm-hmm.
Where you react with shallow pan of food or fork and knife.
Yeah.
Yeah. All right. Well, we said the poll was closing, but it's tied.
It's tied. We'll just wait another
People
minute.
in the audience, please vote.
Please cast your votes. JavaScript or Python example funcs player. Oh, also, the other announcement today is just Sprint Tournament is next Monday. Get hyped, get prepared. By the end of this week, you should be able to build a bot that like hopefully kills the other people. Is that a new React? It is. You should hopefully be able to build a bot that like can like sufficiently attack and like do all the things a bot should do.
The tournament is Monday, you said?
The tournament is Monday, yeah. Oh, so the tournament itself is Tuesday, but submissions will close Monday night.
Oh.
Yeah. Why? How is it still tied? What is this new React?
UE intensifies.
Huh. Okay. Great.
All right, people who just came in, would you rather us do the lecture in Python or JavaScript?
Okay, that sounds like a pretty resounding Python. So,
All right.
poll is closed. We'll be coding example funcs player in Python. Great. So the focus of today's lecture is navigation, making having your units go where they want to go, making sure they do basically like if you want to get somewhere and like do something, that's what today is about. And if you aren't familiar with where example funcs player is right now, we are currently coding on like this building a crusader and then like having these crusaders. And so what we're doing over here is that basically if just a review of last time, we're going to look at all the visible robots. We're going to look at them and we're going to see if any of them are the other team. And if they are, we're just going to go ahead and attack them. And that's our current strategy right now for attacking. See it, if it like moves and it's not me, we should kill it probably. And this part is the part that actually attacks. Please note that if you do one of the actions that is once per turn, say attack, move, mine, give, build, those things, you have to return that. Just like calling self.attack and then not returning the value that gets returned by self.attack will not actually make your bot attack. However, if you do self.signal without returning it, because signals you can send signals while doing other actions, you don't have to return that. So just be sure to do that when you're writing up your bot. So today we're going to focus more on this part, and this is like so currently what our bot does is it chooses a random direction and then moves forward if it doesn't find something to attack. And while this is it sometimes works, like maybe your bot will just randomly fumble onto the enemy castle and kill the enemy castle, and sometimes it doesn't. So maybe this bot will work. We're going to reduce that variance by a little bit by being able to path. So one of the first things that you can take advantage of is that these maps are either horizontal or vertically reflected, which means if a bot was to go to its horizontal or its vertical reflection, one of the two, you'll probably encounter the enemy castle, and if we have this lovely attacking code, we'll probably attempt to kill the enemy castle. So that's sort of the goal for right now. Let's try to get to the enemy castle and kill it. Pretty straightforward. So working on this crusader, we're going to start basically writing movement code. And so there are a lot of ways that you can handle movement in Battlecode, and because you're given a full view of the map besides the robots that are moving on top of it, you actually have a lot of like different like algorithms and plans that you can have for moving. Today we're going to be focusing on a really simple algorithm that just looks at the tiles around you and tries to move forward. So we're going to start with that. So we're going to create, first of all, you're probably going to reuse a lot of this like navigation code. So if you're writing in one giant robot.py, it's probably not going to be that fun afterwards. So we're going to create a new file, and it's going to be called navigation.py. And so currently right now, yes?
Do you have the number for the chicken guy?
The number?
Yeah.
It's my phone number.
Oh, do you have the number they called you at?
It's my number.
I'm so confused.
Okay. Stream, hold on one second. What's happening?
Did they call you? Did they call you?
Arvid has my phone right now. And I told Arvid to go when they call me.
Okay, I think they call. Okay, never mind. Don't worry.
Oh, okay.
Put in the password.
Yes, but you can still like answer a call if it's locked.
Okay. Can I call back a call? It's locked.
No, just hand it to me and I'll unlock it when the time comes. Okay, sorry, technical difficulties, everyone. By technical, like chicken-related difficulties. Okay, so let's start with this. So now we're going to start building our navigation library. And if you're building, other files inside the same directory as your robot, all you have to do to import it is just the same way at the top. Here we can call it, this one's called navigation.p. We can do something called import navigation as nav, just because we like short words, right? So we can start building this navigation. So what we're really interested in doing is being able to move from one place to the other. So the first part is that we're going to set ourselves a destination. So at the very beginning, we're going to set our destination equal to none. And we'll calculate that on the first turn. So on the turn, so if we're not attacking, we're going to start moving. So if we do not have a destination, and just checking not self-destination, that returns true if it's none. And so we're going to try creating it. So we're going to go into this navigation.py because we might feel that like this like code might be used later on, and it might be useful to build out this library. So we're going to create our first function, and it's going to be called def reflect, and it's going to be your current location and a full view of the map. Great. And we know that we are either horizontal or vertically reflective, so we're going to just include that as one of the arguments. So is horizontal reflection. Great. And so this is the part where I sort of just pull out of my Ready Bake Oven some part of the code that actually does this. Yes, here we go. Reflect. Great. So over here, we have a little bit of code that actually just reflects your location. So over here, location, what we're expecting location to be is a tuple of x comma y. And what we're going to do is that the vertical reflection just looks at the, just reflects the x position, and the horizontal reflection will only reflect the y. Great. And is horizontal. If we are at a horizontal reflection, we're going to return hreflect, unless for some reason hreflect happens to be blocked. And this is useful because if the hreflect is blocked, that means that like we're actually not, this isn't actually horizontally reflecting because we're on a passable tile, and the horizontal reflection is no longer on a horizontal tile. The same thing for vertical reflection. We're actually going to return it only if the full map has the reflection as a passable tile. Great. So this is our first part. So this will return our new destination. So self.destination is equal to nav, which is what we called our file, dot reflect. And if you're using, and most like editors will help you with just typing out all of these arguments. So here we go, self.map. And we're going to just say true. Yeah, like let's just assume it's a horizontal reflection. Why not? Great. So then the next part. So now that we're moving towards what might be our enemy location, let's create a goto. Let's create some sort of function that helps us actually get to the next location.
It might be good to clarify that we're going to push all this code as soon as lecture's over, so there's no need to like hurriedly copy it down.
Oh yes, please don't try to like copy me as we go along. All of this, like this navigation.py itself will be uploaded to example funcs player. So for right now, you can just follow along, and also maybe like write code that you think would be helpful in addition to this, but you don't actually have to write this yourself. We'll be handling that. Okay, great. So we're going to create a simple goto function. And so we're going to just build this up incrementally. So we're going to say new direction is equal to nav.goto. And we're going to put our current location. Oh, I actually never initialized location. So location will be self.me x and self.me y. Great. And so that's where we currently are. So we're going to go from our location to the self.destination and not worry really about anything else. Great. So new direction. So for right now, even though a lot of the units can move like multiple tiles at a time, we're just going to move ourselves to squares adjacent. And this is a fine thing to do when you're starting out, and it's probably and you can definitely see how you can like augment this to having it move like 2 squares at a time, or 3 squared radius, however much you so desire. So we're going to just create this. So our location and the destination. Destination. Great. And so the difference in their x values is destination 0 minus location 0, because the first in the pair is the x direction. And similarly, we're going to do the same thing for the y directions. Great. So now we have how much they differ in the x direction and in the y direction. So if the dx if we have a dx greater less than 0, we should actually move less than. Oh, is it here? Oh, okay.
Can we bring it inside?
Okay, we're going to bring it inside, but we're just going to finish this like simple version before we head out. So if the dx is less than 0, we're going to set it to -1. And if dx is greater than 0, we're going to set it to 1. So basically, if there is a separation in the x direction of more than 1 or of a positive amount, we're going to move in the positive x direction. And if our destination is behind us in the x direction, we're going to move 1 to the negative direction. And we'll just do the same thing for the y direction, or I can just actually take it, because why not? Go to. Great. There we are. And this is exactly what we were talking about earlier. So in this way, we're going to move one square adjacent us to our location. And so now all we have to do is new direction is equal to nav.goto, and that'll just output our new direction. And so we're going to do self.move new direction. If you haven't seen this like star, I know we didn't really explain it the first time this appeared. What this star does is it sort of unrolls the arguments. This is effectively the same as self.move new direction 0, new direction 1, and if our tuple happened to be longer, or if our array happened to be longer, it would add all of those in as arguments as well. And so that's what that operator does, and etc. We only have a tuple here, so that's what is going on. So now we have this like great moving function. We're going to move probably towards the horizontal direction. So let's try running this. Go over to iterm, make this way bigger, and go over here. And so this is our current. Great. So we're just going to try running this bot. Great. We did something. Cannot read property apply of undefined. Excellent. Nav.reflect self.map. Great. And let's see if this actually ran or not. So we'll go over to our example funcs player, go into the bot, and we were running the examp. Oh, it didn't even finish. And we also just got told to update. This actually is a great time for everyone in the audience to also update BC19. And yes? I'm sorry, what? Huh. You can speak to Guru about this. While we're looking at this, I think it might be a good time just to get dinner. So everyone on the stream, please hold for a few minutes. Everyone here, please enjoy the chicken back there.
I feel like 50% of Python errors just end up looking like cannot read property apply of undefined.
Yeah, that's an issue. So, oh, let's see the Twitch stream if they have anything to say.
So, let's see.
Oh yes, for the Twitch chat, yeah, you can totally come here and just get free chicken. MIT has a pretty lenient policy on just like free stuff in general. So you can come here, waltz in, and take some free chicken if you so desire.
Are we on the stream right now?
We are, yes.
Are you watching me chicken?
Yes.
Chicken fries.
It's a new variety stream.
Great. Um,
I'm actually very confused.
try taking out the pragmas out of curiosity.
Out of Korea. Oh, okay, great. Oh, sorry. We'll take out the pragmas.
It might make the errors make more sense.
Oh, okay, great.
I can't guarantee that, but it might. Oh, it made the errors go away.
Oh, I love it.
Okay. We won't question it.
Okay, great.
we should verify it's doing what we think it's doing, but
Yes, we
Yeah.
should verify that. Oh, there it is. Oh, that's not the right file to upload. I just uploaded some
see how we have
garbage.
like the nice zooming now.
Yeah, I saw that.
So pretty.
Yeah. Oh, okay. That's just what the map looks like. Great. It didn't actually produce anything. If self.step is a less than 10, building a crusade. Did this thing not try to create any crusaders?
I don't see it.
That's exciting. Well, that is all right, because that's why I created branches to all the different parts of lecture.
Really?
Yeah.
That's great.
Like trees or anything?
Hmm?
Do we have any more like plates or trees?
Oh, of these?
Yes.
I think what we have up there is all we have.
So we'll start with
It's possible it's erroring out.
Huh.
Did you try running this code before lecture?
I did, yes.
Oh, and it worked.
And it worked, yeah.
Oh, interesting.
That's exciting. Oh, thank you. Nav.reflect. All right, well, let's start printing things.
Yeah, it does not make sense to me.
What
Like
does?
getting rid of the pragmas would stop an error from happening.
Yes, well, it stops crusaders from being made, actually.
Yeah, so. For those on the Twitch stream who are curious, the pragmas basically enable certain features in Python that we disable by default. And the reason for this is there are certain things, for example, operator overloading, that if you want to support, it means that you have to transform every instance of like a plus into like a dot add, right? And that's a lot of function calls and a lot of overhead, and it makes your code a lot slower. So generally, we try to disable that by default and make it so only if you enable it, then stuff happens.
Oh, exciting.
Yeah.
Let's start reading this. Great. Start turn. Oh, that's just me. Start turn undefined. Castle. Cannot read property apply of undefined.
What line do we think is happening?
So that's exciting. So there are 2 castles, or so I see 1, 2, 3, at least 4 unique robots on the red team, which means one of them is a crusader, even though we ask it to actually output when it's building a crusader.
Oh, interesting.
Great. Let's view this replay.
Yeah, seems prudent.
Yeah, okay, so So these guys are moving.
Can I see the log statement?
Yes, it says type error cannot read property apply of undefined. At function anonymous.
Oh, wonderful.
Great.
um, what is self.destination?
Self.destination is initialized to none, and is when we realize it is none, we're going to create it. And we basically reflect horizontally or vertically to achieve self.destination.
And we're 100% sure that that like works.
Yes. I'm actually curious. I wonder if my current code works on...
Wait, so did you end up trying to pull your old code and see if that worked?
Yes.
Are having trouble with multiple files?
Yeah, I guess I am.
Oh, is that the difference?
No, this is
It's also using multiple files?
also using multiple files, and it seems to be doing fine.
Maybe do a git diff between the two? Sorry, just not git diff, just standard diff between the two.
Oh no, they're very different because this one's like farther in the lecture.
Oh. Interesting.
Great.
There's probably an oopsie.
Okay, well, this self.log no longer actually logs, which is an issue.
That's problematic. Wait, I'm confused. Go back to the initial logs.
Mm-hmm.
All the way at the top. Like we see, it says castle, like each print castle health. So wouldn't that imply that they're not producing a crusader?
Oh, yes. Self.meTurn is correct, right? We'll just check the docs for this.
Let's try commenting out that line.
Which line?
Self.me.turn. Replace it with just like, I don't know, something else.
Let's just get rid of it.
Yeah.
Great. We're just going to try creating Crusaders
until
until...
error because we have an else statement without enough.
Huh?
Isn't that such a beautiful error?
Oh,
It's
yes,
so nice.
you're right.
So informative.
Red. Oh, wait, it actually does tell us what line it fends on.
Yeah.
That's excellent.
I know.
So these things are being created.
So where are we? I think we have people's attention back from the chicken.
Oh, great. So we're currently at... so we're currently trying to live debug why our... Okay, so we're creating Crusaders, and we are creating these... and we're creating... And the only log we get is apply of undefined.
Yeah. So we get a cannot build on an occupied tile, and then we get, okay, so it looks like the error is in the Crusader code, right?
Yes.
Okay, so let's look at the Crusader code.
Okay, great. So we're going to look at, we're going to create our own location, which is just our tuple. And that is correct. And if we don't have a self pump,
Have you tried commenting everything out except the import? Just to see if that's the problem.
everything out besides the import.
Yeah, it's like all the new code except the import.
Oh, except the import.
What is the new code?
New code is right here.
Oh, okay, that's not bad. It's only a little bit.
Yeah.
Ooh, that's
Ooh.
not good.
That is not good.
So let's look at navigation.py.
Let us look at navigation.py.
Looks like we have a problem. Okay.
Oh. Oh, yeah, no, that is a comment.
Ooh, on line 5.
Mm-hmm.
There's an extra bracket at the end.
An extra bracket.
Oh wait, no, that was my eyes, my lag eyes. looks like it should be fine.
Well, let's just comment out this. Oh,
I'm curious what happens if we just take that and try to. Oh, okay, never mind.
okay. Well, we're going to git stash and see if we still.
Get stashed.
Oh, yes. Okay, cool. So if you decide that everything that you've done so far in your commit, or basically anything you've done so far besides from your last commit is maybe bad, you can stash it. And this basically like stows away all of your changes and reverts your current directory back to where it was on top of the last commit.
It doesn't throw them away. It saves
Oh,
them.
no, it stows them away, yeah.
You could bring them back.
Yeah. So once we figure out. Okay, so there's still a navigation.py, but it's not being imported. But yeah.
It still might be problematic if it's not being imported. Let's just try commenting everything in and out.
Oh, okay, yes. Sure. Nope.
So what is different?
There is nothing different.
Could it be a problem that
This-
navigation.py just exists?
Yeah.
Why do we have a package log?
Pretty sure people have been having trouble with multiple files.
Unrecognized package extension.
Someone on Twitch said it's no longer importing .py. So it's not that. But we're not sure that that's true.
Oh, could we've been editing the wrong file?
No, we are. This is the right side. Just because this is example funcs player, and this is the this is the built branch that I created earlier. Great, and now we have node modules.
For some reason.
And we're just going to get rid of this replay just in case it's causing the issue.
What? Oh, did we also rm try touch navigation.py?
Try touch.
So for those who don't know, touch just creates an empty file. Well, that's spooky.
Well, so the spookier thing is that it's currently trying to add this code that no longer. Oh, just kidding. Oh, okay. So no, this is back to where we were at the very beginning. Great.
Good.
We're good. Okay, cool. Great. We reverted all the way back to the beginning, and now we're good. So we're just going to create those functions again. Yes.
Do we know what the problem was?
The answer is no. Yeah. Currently what we are not quite sure what the issue is, but we'll just avoid having multiple files for right now. All right, great. So we're just going to copy over these over here. And basically, this is the same thing from before. Calculate direction in which you want to go from the target. Return dx.dy. We're going to also add in and this is pretty much all we need for right now. And so over here, what we're going to do is also apply this reflect code, def reflect. And this is what we were doing before, where we're trying to calculate the reflection of where we were previous. Great. And so this is basically resetting to where we were earlier. Great. And there is a oh, yes. Great. And they're currently complaining about these pragmas, but that's all right. And the last part Okay, so the last part that we need to get is if. Okay, great. Okay, so we're back to here. We're trying to move. We're trying to move in one direction that's not random. So my coordinate is self.me_x and self.me_y. We're going to delete this. If not self-destination, self.reflect, self.map, my coordinate. And over here, we're just going to say we're always going to try going to the horizontal direction. Oh, yes. And we're also going to actually create self.destination. Destination equals false. Great. Over here. Okay. And the last part is we're just going to start moving towards it. So choice direction is going to be self.calculate direction, and we want a starting location, which is my coordinate, and an ending location, which is self.direction. Great. And we're going to say trying to move in direction, choice direction, and do all of that great jazz. So no complaints, no complaints. Great. We are good to go. Cannot read property 0 of undefined. Great.
Property 0 undefined probably means that we had,
A real error, yes.
yeah, like probably a 2D array where the first index is wrong. And we get that wrong from that.
Yeah. Great. Oh. Self.map is correct.
Should we do the comment things out until it doesn't work, until it doesn't break again?
Okay, yes, let's do that.
What if you comment out all of the new stuff that isn't a function?
That isn't a function?
Yeah, so like maybe adding the functions is the problem, which would be silly, but
This is
like
exciting.
if we keep those two and then comment out everything else, that's all right. Wait, so now this is commented out. This is back to like how it was at the beginning, right?
Yeah.
Okay, so that should just work, unless there's an indentation problem or something. All right, great.
Great.
Okay, so let's comment in the functions, but not that part.
Comment in the functions, but not that part.
Yeah,
Great.
just to see if like declaring the functions is like causing some problems somewhere. Like maybe there's a syntax error and it's just, I don't know. Great.
Great.
Okay.
All right, let's continue on, and let's comment in
Yeah,
part of
let's
the code. Wow, great. And let's see if it shows a location to go towards. Oh, we actually can't see that far.
Just run another one.
Yeah. Great. Snagged it. All right, moving towards, okay, great. So now we're going to calculate a direction. Debugging at its finest.
Yay.
Great. Okay, so we figured out where it doesn't like us. So Over here, we want a start and a target. Start.
Our start and target, the shape that we expect. Maybe just log start and target before doing calculator.
Yes. So calculator, it's a tuple, and
Yeah, what's self.direction?
oh, thank you.
Oh.
There we go.
That'll do it.
That'll do it. Great.
Oh, that won't do it. That will do it.
Sorry, y'all. Great. So now we have something going on. So if we went and actually watched this replay, and we're going to see that, yeah, we're like trying to move over here, and there's a wall. And that's super unfortunate. And actually, just so that we can be a little bit more interesting, let's have only half of our units go towards, randomly choose half of our units to go towards the horizontal direction, and half of them try to reflect in the vertical direction, just so that we can maybe suss out like if we send half of our units towards the right direction, hopefully we'll kill something. So thankfully we have a great source of randomness in our code. It's actually our ID. So we're going to go horizontally if our ID is not divisible by 2, and we're going to go horizontally if it is divisible by. Sorry, it'll go horizontal if our ID is divisible by 2, and we're going to go vertically if we're not divisible by 2. And that'll send half of our units towards one direction and half of them towards the other direction. Great. And it looks like we actually have action going on in this one. I just saw a few attacks. Great. So if you couldn't read all of those logs, we can also just play it over here. Great. All right, so we're going to start it. So over here, we actually do end up seeing some action going on. You can see that a lot of these crusaders over here are trying to go towards the enemy castle, and they're actually just duking it out on this battlefield in the middle. It looks like blue sent in more crusaders than red did, so fortunately, blue actually went and conquered red's castle, and that's awesome. So now we have a bot that actually can sometimes kill the enemy bot, and that's great. Obviously, we're not doing the best job we could. You can see over here, this one's sort of stuck because it's trying to go over here, and there's like this giant wall. And so that's the next part of actually pathfinding. Like, how do we get around an obstacle? And so again, since you have full view of the map, you could write algorithms to sort of look at the full path from one place to the other and sort of make your way from there. Unfortunately, you have a lot of issues with that, especially when you have a lot of these. If you have a lot of units all piled up at once, and you're sort of like, oh, I want to go to this red square over here, but there's like this unit in the way, and it's like maybe it just stays there for a while, and this blue square over here is always trying to move in that direction, but you don't really get much out of it. And so really we want to be prepared for what will eventually be large army movements, and also just moving around, navigating around our terrain in general. And it turns out if we're moving in a straight line and only really accommodate when we can't move in a straight line, we're going to do a pretty good job of navigation. So that's the next part. So over here, what we want to do is sort of just navigate. Instead of going over here, we want to rotate our movement into one of the nearby directions and then continue on. So here we can make those changes over here. So what we're going to do is that we're going to have basically create a dictionary of all of our directions, starting from, so this is directions, and it's just going to be 0, -1, which is north, yes, -1, which is north east. Yes. -1, 0, which is
-1 is northwest.
northwest. Yes. Yes, northwest. So this is west, and this is going -1, 1 is going to be southwest. 0, 1 is going to be south. -1 or 1, 1 is going to be southeast. 1, 0 is going to be east itself, and then 1, -1 is going to be northwest. So now what we've done is basically created all of the 8 directions in clockwise order. And that'll be great for us for later on when we're trying to rotate. So now what we want to do is refine this code a little bit. Instead of just saying, well, we're going to go straight to our destination and not really try to account for impossible terrain. Instead, we're going to say we're going to go in the right direction until we actually hit something, and then try to rotate into another direction. And that's like a pretty good, So we're going to just quickly take some rotation code. So over here, we're going to create this function called rotate. And all this is going to do is going to take your original direction and then an amount. And so what we're going to do is direction is going to be, the new direction is going to be the original direction plus some rotation amount. So self.directions. And over here, we're getting the index of the original direction and then just adding some amount to get one of these new directions. So if we're going to rotate by an amount 1 from maybe say north, we're going to rotate over from -1, 0, -1 over to -1, -1. And this is just going to be a little bit of simple code to transform our directions using rotation. Great. And over here, what we're going to do is now basically our choice direction is going to be this way. And while our choice direction is impassable, we want to just rotate towards another direction. And so thankfully, we're just going to, so what we're going to do is create this other nice check over here, which is called is passable. And that just checks that what we're trying to go to is actually still possible. So over here, what we're going to do is this helper function is going to take in the full map, our current location, and then the direction we're trying to move towards, and then the robot map. And so what we're going to say is if we're outside the bounds of the map, obviously we should stop. If we actually hit something, if our full map says that it's impassable, we should also say it's not passable. And if the robot map over here, if you check the specs, a robot map will be -1 anytime you can't see it. It'll be the ID anytime you can, and there's a robot there, and it's going to be 0 otherwise. So if the robot map, if indexing into the robot map actually gets you greater than 0, you should also return false because the robot's there. You want to be a little bit careful. It was noted in the Discord earlier today that robot map actually takes in the Y argument first, or like basically all of our maps take in the Y argument first and then the X argument second. And this is a little bit counterintuitive to like what you might expect. But if you were just using, or like if you're used to math and coordinates, but this is really because you can imagine the arrays are laid out like this in your coordinate system. So each of these, because 2D arrays are just arrays of arrays. So actually the first index chooses which one of these horizontal arrays to go into, and that's your Y position. And then the second one indexes into one of these, which is your X position, which is, so even though it doesn't make much sense to choose Y before X, this is sort of why we do it, and it's pretty commonplace in most 2D grid code. So over here, now that we have this code that just checks is passable, we're just going to quickly copy over a little check over here. Yes.
Nothing.
Oh, okay.
I just get bored watching 5 seconds behind.
Oh, yes. Okay, so while our current location is not passable, so the first thing we want to do is, given the self-direct, the choice direction and self.getVisibleRobotMap. Okay, great. And we're going to actually just get rid of this code over here because that's spoilers. Over here, what we're going to do is we're going to turning from and then our choice direction. And what we're going to say is our new choice direction is going to be the rotation of our current choice direction by 1 in the clockwise direction. So over here, what would have happened if we had these if we had this sort of situation going on? We're trying to move over here. Instead, we're going to move over to this one, and then afterwards we can just path our way correctly towards our end location. Everything's pretty happy and everything's pretty simple. So that's sort of where we're at right now. And we're going to run this. Great. Args.apply failed to initialize. Oh, okay, well, there is an error over here. Too many positional arguments for method call. Oh, that's a Pyland. Okay, great. And over here, too many positional arguments for method call. Over here, def is possible. Oh, thank you. Def is. And over here, great. And great. Check that there are no errors. And there are still errors, so we're going to just quickly go in and swoop in and save the day. Okay, great. Self.directions. And remove that. Great. Everything looks clean and dandy. Failed to initialize type error. Great. Get visible. I'm just going to get rid of that and see if it's still great. Full map, location, coordinate direction, and robot. Great.
So it's happening before you try to rotate.
It's happening before I try to rotate, yeah.
Is it the while like is passable thing?
Yeah, I think so.
If we comment that out, does it work?
Yeah, that's where we were before, I think.
Oh, okay. Yeah, I believe you then.
Okay, cool.
You could just print is passable or something, or log is passable first.
Log is passable. Great. All right. Actually, we're sort of running far in time. I actually just have like the replays, and we can continue on. But we can also see what's going on here. Great.
I feel like it's useful to have
Yeah.
examples of debugging.
That's true. Self.log. This is coding in action.
Yeah.
Great. Okay, great. So it's over here. Self.is passable. The map, my coordinates, the choice direction, and the get visible robot map.
Is that the first place we use get visible robot map? That might be breaking it.
Yes.
What if we just logged the whole robot map?
Oh, yes. Huh.
Rip.
Get visible robot map is no longer working. Actually, let me just try commenting out what else we've done so far.
I mean, if you commented out that log statement.
Let's find out.
Sad.
Well, that's exciting. Oh, just kidding.
Oh. Rip. Okay. Mm.
I was gonna say, not a complicated function.
Yeah. Oh, exciting.
Directions. Why?
Directions. Comma, comma, comma.
Oh, there's some missing.
Oh, thank you. Great.
There's another one.
There's another one missing? Oh,
Mhm.
great.
It's weird that your linter didn't catch that.
You're right. That is quite strange.
Maybe I thought it was multiplication.
Oh,
No, that doesn't make sense. I don't know.
yeah. Great. So we're going to get back over here.
Wow. See, you don't need helpful error messages to debug. You can debug anything by commenting stuff out.
Oh, there is a point to this. Yeah. Okay, great. It looks like we're doing something. All right, so we saw a few attacks, and we're just going to stop it here so that we can sort of see what's going on. That is the replay. Go over here, and we're just going to play this replay. All right, great. And hopefully this will be a cool example.
Whoa, you can zoom the viewer?
Yeah, you can zoom the viewer now.
I didn't know
Okay,
that.
so it seems that this... Okay, this one's not pretty interesting, you can sort of notice these robots over here are actually being pretty cool and like navigating their way around objects. These robots, which are actually doing the real action because they're going and facing the other castle, aren't just have a straight line, but that's pretty cool too. Over here, you can sort of see that these robots over here have actually pathed their way around this sort of obstacle, and that's pretty cool. And yes. What now?
He thinks we've reversed the y and x coordinates.
Oh, we've reversed the y and x coordinates? Oh, really?
Possibly. I don't know. I mean, it's hard to say because they both go both ways, but like...
Oh, that's true. Do you know if we path yx or xy in the map?
It should be yx. I think it's yx everywhere.
It's always y.
It's always yx.
Okay.
I think it should be fine.
Yeah, would you like to clarify or?
I guess not.
Okay. So yeah, that's pretty cool. And if we stop the lecture right now, you might try to actually just like continue with this. Please don't, because it's not the best. This is still not like something that'll always get you towards your ending location. So we're just going to go over here and go into loop.bc19. And over here, I've actually saved a file where our current bug nav does something pretty funny. If you'll see these over here, they're going to go over here. They're going to see that there's a wall, try to rotate around it, and then realize, oh, I can actually just go forward now, and just sort of do this like little loopy thing forever. Great. So, and if you also notice here, there's this like cute little like circle of Crusaders just like chilling out at their final location. But basically, overall, what we've accomplished is a pretty simple bug nav that doesn't actually really get anywhere if our obstacles are a little bit more complex. So actually, a pretty simple way to get around this is by what our previous lecturer Matt called stinky paths. So basically, what happens over here is that you have this like gigantic wall over here, and basically what your code will eventually do is try to wrap around itself, where it'll go over here. If you have this wall, yeah, so if you have any like wall that goes around like this, basically what's going to happen is that your bot's going to move up here, then it's going to move over here, and then it says, oh, wait a second, I really like going down here because that's like closer to my destination if our destination was over here. I think right now we're doing this clockwise, so it's actually going to rotate clockwise, go over here, and then realize I should go over here to like meet this like square over here, and then it's going to go over here. And so a solution over here is to say, is to imagine that our bot is going to leave behind a really stinky path behind it. And I've already used green, so let's say let's say like we're going to create these like little like fart bubbles everywhere. If I could draw a fart bubble. There we go. So that's like a fart bubble. And like basically like you move over here and you like create this fart bubble. You move over here, create this fart bubble, and then you try to move over here, but you said, I've already been there. I really shouldn't go back. And then it's going to path find over here. And basically, this gets around obstacles, and because you're never repeating the same location, you're actually going to always get to your final location, albeit a little bit messily. So that's sort of where we stand. That's sort of like where we could stand with like having a fully functioning navigation system, and that's actually where the example funcs player sort of sits right now once it'll be pushed. And so it's currently 8 o'clock, so I think we'll just go through the other sort of like bug navigation ways that you can consider. So this like sort of pathing thing does take a lot of extra like paths. So other sort of things that you can do. One thing that you can consider is to have once it sort of reaches an obstacle, what it can do is sort of just like path around and just like patrol the entire perimeter. And then once while it's doing that, it can try to find where the closest point is to our destination. So it's going to go around here and it's going to realize, oh, like over here, this is like the best place. This is the best place I can go to actually get closer to my destination. So once we patrol the entire perimeter, we're just going to go back to this place and then sort of move our way towards the destination. And this is a pretty good pathing algorithm. You'll notice that's a little bit extreme in that like you have to sort of go around the entire perimeter of everything. But again, this sort of guarantees that your bot eventually makes it to the end. And you can also, while you're looking at all of these, you can sort of imagine the different ways in which these, like this one will take a little bit slower, and that one might take a little bit slower in this situation. Another idea to navigate your bots. We're not going to actually implement these just because we want to keep example funcs player easily beatable. But basically, you can imagine that there's a line connecting basically you and your destination. And another thing to do is once you hit a obstacle in your way, what you can do is, if I could stop creating a line, is basically navigate around this until we reach this line again. And once we realize that we've intersected this line again, we can continue going and pathing towards our final destination. And so both of these work perfectly fine if you're able to implement either of these. They actually work better in different situations, and believe me, we'll definitely make maps so that like pathing is an important part of your strategy. Any questions so far? Does the Twitch stream have any questions? Twitch stream is happy. Over here, do we have any questions? Okay, great. So that sort of leaves off where navigation is today. We've covered like 3 different ways, the last 2 pretty quickly, in which you can actually navigate from one place to the other. And this is going to be useful for anything because you're going to be navigating. Just be really careful because remember that like not only are you trying to move one unit at a time, you're actually going to move a lot of units at a time. So you can imagine that you have situations where this one's trying to go around and this one comes over here and it's trying to move past it. There's going to be a lot of issues when your units start to clump, especially if there's sort of like this choke point over here. You can imagine that like your paths have to accommodate for how your units are going to interact with each other, especially since because you have moving units, basically you're having a slightly changing obstacle terrain as you move around. That's all for today. Thank you. Oh, yeah. Is that a question?
No, that was a Q&A.
Oh, thank you. Yes.
If people have questions or like want more help getting set up, getting started,